Okay, so we looked at this problem once before. I thought it might benefit some people if I went through it kind of slowly so that you get an opportunity to actually follow along with what's happening on your calculator. We've got little Dudley over here. Little Dudley is, his little jumper attaches to the doorway, and he sits in this little thing and he kind of hits the ground and pushes up, and he continues to go jump up and down continuously. So little baby Dudley is a very happy little baby as he continues his jumping up and down. If you can imagine what that looks like on a trig point of view, if all we look at is his height, he starts off, he goes high, then he comes and he hits the ground and he pushes off, and you can easily see how a trig graph can model his height off the ground. So that's what this equation is that I went ahead and wrote up here. Let's take that, put it in our calculator. So just to kind of go slowly, this is largely a calculator problem. I hit the y equals -6 cosine. Now I've got this 2 pi over 3, so I've got to put that in its own parentheses. 2 pi divided by 3. That's my fraction. So I closed off the fraction parentheses. X, close the cosine parentheses, and I've got plus 14. Okay, so I've got my equation into my calculator. Yay me. Start looking at the questions that are being asked. Y stands for his height off the ground. And we want to know, first of all, what is his lowest height on the Johnny jump up? Well, my calculator can do all this for me. My calculator can do this for me by using the table features. I just hit second window. I'm going to tell the calculator, let's start my table at 0. That 0 stands for time 0. That's what X stands for, is the number of seconds. So at 0 seconds, where's Dudley? Now if I hit second graph, I get to table. And what you can see by looking at this is we can see that Dudley is jumping up and down. He starts off at 0 seconds. He's at 8 inches off the ground. At 1 second, he's at 17. At 2 seconds, he's still at 17. So there's some things going on here that we're not seeing because we're only increasing these numbers by 1 second. So what I'm going to do, let's get rid of that and let's get rid of all this writing I've got here. What I'm going to do is I'm going to go back into here and I'm going to reset my table. I'll go to table set. I'm okay starting my table at 0, but changing, that triangle table means the change. How do I want the x's to increase? I don't want them to increase by 1 second because I'm not getting enough detail. How about a quarter of a second? And I'm just guessing quarter of a second might give me more information. See what happens when I look at my table. Now when I look at my table, I see all kinds of different information here. I've now got information increasing. These values under the X column are increasing by a quarter of a second. I get a little bit more detail about the heights off the ground. I can still see that his starting height is 8 seconds. And I can identify quickly then what his lowest height is. If I take a look at that table and I scroll down little by little, I can see, oh, look what happened there. He hit a high at about 1.5 seconds, and then he started going down again. How low does he go? He goes down to 8 seconds. Any further and he starts going up again. So when it asks what is his lowest height on the Johnny jump up, I'm going to go with 8 inches off of the ground. That's his lowest height. What's his highest height on the Johnny jump up? Well, if you take a look at that table, did he ever go higher than 20? Looks like 20 is the highest number he's got. So his highest height would be 20 inches off of the ground. Ask your parents if they ever put you in a Johnny jump up. Those things were a lot of fun. My kids loved them. I think that would be just sort of fun to play with right now, wouldn't it? How long does it take him to complete one full cycle of jumping up and down? How long? We're looking for time. Where's time again? Oh, time is in the X column. So let's take a look and see if we can trace how long it takes us. I'm going to try to go back to 0 for my start. Take a look at that table and see how long it takes for him to get to 8 inches off the ground again. So I scroll down. At 1.5, he's got his high of 20 inches. Where does he get to 8 inches again? There it is. He gets to 8 inches at 3 seconds. That time is in seconds. So how long does it take him? It takes him 3 seconds to complete a full cycle going up and down. Next question says, can I read that from here? Next question says, at 30 seconds, if he's jumping in this for 30 seconds, at exactly 30 seconds, where's his height? How can I do that quicker? Then scrolling, I can go table set and say, hey, I want to know what's going on at 30 seconds. Hit table, and there it is. At 30 seconds, he's at one of his low points. At 30 seconds, he's at 8 inches off of the ground. Whoops, 8 inches off of the ground. 8 inches off of ground. So hopefully this gives you a little better idea about what's happening in terms of using your calculator to help you with some of these really cool questions, practical questions. Have a great day. Tell me what questions you have.